Hello again. In the previous lesson, we learned how to read and write quadratic functions in vertex form. In this lesson, we'll use vertex form, an axis of symmetry, and intercepts to graph quadratic functions with efficiency. So we want to start with these rules. Start with vertex and axis of symmetry. Use symmetric points on both sides of the axis to build a graph. Y-intercept is a function of 0. The x-intercepts occur where f of x is equal to 0. And then the sign of a determines the parabola, whether or not it opens or closes, okay? As we studied in the previous lesson. Now let's continue. We want to look at the first example. We want to graph this function and state the vertex and the axis of symmetry and then choose at least 4 symmetric points. Okay, so remember the function is f of x equals a parentheses x minus h squared plus k. So again, we want to compare this with this expression here. So the vertex is obviously h k, which ends up being 2, -3 in this case. Okay? Now, the axis of symmetry is the vertical line that passes through the vertex. So the axis of symmetry is just a straight line, which would tell us that x is equal to 2. And again, this is the axis. Okay. The axis of symmetry is x is equal to 2. Now, we need to choose some x values equally spaced around x is equal to 2. So let's just say we'll use 0, 1, 2, 3, and 4. So let's evaluate. Let's say f of 0. If we do f of 0, if we put 0 in here, and I want to save some space, I'm not going to write all these out. So if we put 0 in here, 0 minus 2 squared minus 3 is going to give us 2 squared, which is 4. 4 minus 3 is equal to 1. So if we evaluated this expression for 0, we'd end up with 1. If we evaluated the expression for 1, let's see, we put 1 in there. 1 minus 2 would be 1. 1 squared is 1. 1 minus 3 would be -2. If we put the 2 in there, let's see, that would be 0. 0 minus 3 would be -3. If we put the 3 in there, it would be, let's see, 3 minus 2, so it'd be -2. And then finally, if we put the 4 in there, 4 minus 2, so it'd be 4 minus 1, which is 1. Okay. Now, so we have the points essentially 0, 1, 1, -2, 2, -3, 3, -2, 4, 1. So essentially, we can plot the vertex first and then plot the symmetric points. And then the graph opens upward because A is equal to 1. So if we were to graph this, the vertex would be, I'm just going to, so the vertex is 2, -3. So 2 over 2 down 3. Let's just put that here. Okay, 2, -3. And then so let's just say, so it'd be 0, 1. So 0, 1 would be, let's just say here. Okay. And then 1, -2. So over 1, let's see, plot the vertex first, then plot the symmetric points. Okay. Vertex, so 0, 1, then 1, -2 over 1, -2. This is not going to be perfect. And then 2, -3. Over 2, -3. It'll be something like this right here. Okay. 2, -3. Actually, sorry, 2, -3 would be here. So get this out. And then over 3, -2 would be here. Then 4, 1 would be here. So essentially what it would look like is it would look like this. Okay. That's basically what it would look like. All right. All right, let's continue. We don't want to linger on too much on that one. So f of x equals -2 x plus 1 squared plus 4. State the vertex, axis of symmetry, and whether it opens and the domain and range. Okay, so we have our function here. And again, we want to look at we want to write this over and over so that we can commit it to memory. X minus h squared plus k. So the expression x plus 1 means, if you see x plus 1 in there, it basically means x minus a -1. That's what that means, okay? So this tells me that h is going to be -1 and k is going to be a +4 per this equation. So the vertex is -1, 4. That's the vertex, okay? Okay. The vertex is -1, 4, and the axis of symmetry is x is equal to -1. Okay. We have a coefficient of -2, which means it's going to open downward. Okay. So this graph is going to open downward because of the negative, and it is a parabola, and the 2 indicates that it's going to be vertically stretched. Okay. So it opens down. Vertically stretched by 2. The domain is -infinity, +infinity. And let's see, we would see a maximum value, right? Because this would be the vertex. We would see that maximum value of 4. So the range would be -infinity because it's going to go down forever. And then 4 would be the peak of that, okay? Which is the max of 4, right? Let's see. We could graph this, but we're going to forego this and just move on to the pause and try. Okay, so you try the pause and try question. Okay, so the pause and try question is, we have 1/2 x minus 4 squared minus 2. Create a table using these values, then state the vertex. Okay, so when we think about this problem, we have to understand something. We already know the vertex because the vertex is right in our face here. We don't have to change it this time. So the vertex is going to give us 4, -2. Okay. Then we can evaluate the given x values. Okay. So essentially what we can do is we can substitute the 2 in there, etc. When we put the 2 in here, let's see, we're going to end up with g of 2 equals 0. If we put the 3 in there, let's see, 3 minus that, we're going to end up with -3/2. If we put the 4 in there, we're going to end up with -2. And then the 5, you can verify all of these, -3/2. And then the g of 6 in there, this will generate a 0. Okay. So we can essentially draw a table from this. We would have x is 2, 3, 4, 5, 6, and then the output would be 0, -3x, -2, -3, excuse me, -3/2, -2, -3/2, and then 0. So the values repeat symmetrically around this 4, okay, around x equals 4. All right, let's continue. Example number 3. For f of x equals x squared minus 4x minus 5. All right, we're going to find these things here. So let's write, first of all, x squared minus 4x minus 5 equals 0. Okay, so because we have to do this to find the x-intercept, so we're going to go ahead and do that right away. So to find the x-intercepts, we set this equal to 0. Then we got to factor this. Okay, when we factor this, we are going to end up with x minus 5, x plus 1. And the way you have to think about it is what two numbers multiply to give me -5, but add up to give me -4. Okay. Then we're going to set each factor equal to 0. So x minus 5 equal to 0. That's going to give us x equals 5. X plus 1 equals 0. That's going to give us x equals -1. So the x-intercepts are 5, 0 and -1, 0. Okay. Now let's look at y-intercepts. So a y-intercept is when you set x equal to 0. So we have f of 0, 0 squared minus 4 times 0 minus 5. So f of 0 equals -5. So this would be 0, -5. So the axis of symmetry, right? The axis of symmetry is halfway between the x-intercepts, okay? So x, if it's halfway between the x-intercepts, we would write it as x equals -1 plus 5 divided by 2, okay? -1 plus 5 divided by 2. X equals 4/2, x equals 2. So the axis of symmetry is x equals to 2. Now, the vertex. So to find the vertex, we need to evaluate the function at x is equal to 2. So we take the function. So it's going to be 2 squared minus 4, 2 minus 5, f of 2 equals, this will be 4 minus 8 minus 5, which is going to be -9. So the vertex is 2, -9. And again, since a is equal to 1, the parabola is going to open upward in this question. Okay, let's continue. Example number 4. So for this expression, we have to explain why the vertex form gives a faster graph than making a longer table. So the function is already in vertex form. So we can immediately know that the vertex, and the direction of the opening, right? Because we have f of x equals -x minus 3 squared plus 9. So the vertex is 3, 9. And the axis of symmetry, which is x equals 3. And this has a -a, so it's going to open downward. Okay. So this is faster than making a long table because the most important graph features are already visible. Okay. So you want to take this step if it's available for you. Now, in order to find, let's see, x-intercepts, what we can do is we can say, all right, x negative parentheses x minus 3 squared plus 9 equals 0. We can subtract 9, negative x minus 3 squared equals negative 9. We can divide by this negative over here. There's negative 1 to get rid of that negative. So x minus 3 squared equals positive 9. So notice now what we can do, we can take the root, square root of both sides. This will get rid of that. So, and then this will make this a plus or minus 3. And then essentially you have the x-intercepts. Okay, we have one where we're gonna, we have a positive 3. So what we have to do is we're gonna add 3 to the positive 3. So we're gonna have one where we have x is equal to 6, and then we're gonna have another where we're gonna subtract. We're gonna add a 3 to a negative 3, so it's gonna give us 0. So on one hand, we have 0, 0, and the other hand, we have 6, 0. Okay, so that's our x-intercepts. The y-intercepts is when it occurs when you set the function equal to 0. So, or excuse me, you set x equal to 0. So the way this would look is, um, we'd say 0 minus 3, negative 0, or excuse me, negative parentheses 0 minus 3 squared plus 9, which is going to give us negative 9 plus 9, or f of 0 equals 0. So that's our y-intercept. Okay, and then this is our x-intercept. Okay, common mistake. A student plot points only to the right of the vertex and guesses the left side. Explain how the axis of symmetry fits the problem. So a parabola is symmetric. That's first of all. And that means that the axis of symmetry is like a mirror, right? So just to kind of give you an idea, if you have a parabola, the axis of symmetry runs directly through it so that you'll have a mirror image of what you're looking at. Okay, that's how we call it, the axis of symmetry. Now, if a point is 2 units to the right of the axis, right? If a point is 2 units to the right of the axis, there is a matching point 2 units to the left of the axis, right? So the axis of symmetry is x is equal to h, okay? And that point pattern looks like this. If you have essentially h plus d, comma y, that essentially tends to h minus d, comma y. So if you add or subtract, you're going to find the location of that point on either side. Okay, so we don't have to guess. We can use symmetry to reflect the point across the x, and that gives us a more accurate graph. All right, let's review. All right, so just review these quick rules. You start with the vertex and the axis of symmetry. Remember, the axis of symmetry is x is equal to h. Okay, use symmetric points on both sides of the axis to build the graph. Y-intercept is setting x equal to 0. The x-intercept occurs where you set the function equal to 0. And the sign of A determines whether the parabola opens downward. Okay? All right, and again, thank you for watching.